Welcome to the Explainer. If you're managing modern applications, you already know that keeping your software updated without disrupting your users is pretty much the holy grail of operations. Well, today, we're focusing squarely on how to achieve exactly that using Kubernetes. We're going to unpack the actual mechanics of zero-downtime updates, explore the native tools Kubernetes gives you right out of the box, and even look at some advanced strategies to make your rollouts absolutely bulletproof. I'm super thrilled to share this with you, so let's get right to it. So here's the fundamental question we're tackling today. How do you update an app without anyone even noticing? In modern software delivery, we're up against a massive challenge. Users expect our applications to be available literally 100% of the time. But at the same time, developers are expected to push new features and updates multiple times a day. We essentially have to change the engines on an airplane while it's still cruising at 30,000 feet, completely without spilling the passenger's coffee. It sounds crazy, but Kubernetes was built from the ground up to solve this exact problem, and it honestly does it brilliantly. To get us there, here's our roadmap for today's explainer. First, deployments versus ReplicaSets. Second, mastering rolling updates. Third, advanced strategies like blue/green and Canary. Fourth, the anatomy of a deployment. And finally, number 5, your rollback rescue toolkit. Let's kick things off with section 1, deployments versus ReplicaSets. Okay, so a really common point of confusion for beginners is the difference between a replica set and a deployment. It helps to think of a replica set as your floor manager. Its entire singular purpose is just to maintain a stable set of replica pods running at any given time. If a node suddenly fails, the replica set brings up a new pod to replace it. Simple, right? But the thing is, it doesn't actually know how to gracefully update to a brand new version of your software. And that is exactly where the deployment comes in. The deployment is the executive. It manages the replica sets on your behalf. When you want to roll out a new version, the deployment orchestrates the whole process, creating a new replica set for the new version, scaling it up, while very carefully scaling down the old replica set. The core philosophy driving all of this is desired state versus current state. You don't ever tell Kubernetes how to update your app step by step. Instead, you just declare your desired state. You say, hey, I want 3 pods running version 2.0 of my app. That's it. The Kubernetes deployment controller then looks at the current state, notices it doesn't match what you asked for, and continuously works at a controlled rate to make your desired reality the actual reality. This infinite loop of reconciliation is literally the engine that drives Kubernetes. Moving right along to section 2, mastering rolling updates. Now, the crucial point here is understanding the math behind this strategy. A rolling update is the default deployment strategy in Kubernetes, and it relies on 2 specific parameters to control the update: maxSurge and maxUnavailable. MaxSurge basically dictates how many extra pods can be created above your desired amount during the update, giving you extra capacity. Meanwhile, maxUnavailable dictates exactly how many pods you can tolerate being offline. By default, both of these are set to 25%. So to put that into perspective, if you have 4 pods, Kubernetes will first create a 5th pod with the new version. That's surging your capacity. Only when that new pod is totally ready will it terminate one of the old ones, ensuring you absolutely never fall below your availability threshold. Let's look at the progressive nature of a rolling update in action. It really is like a carefully choreographed dance. Step 1, it spins up a new pod in the new replica set. Step 2, it actively waits for that new pod to report as ready and fully capable of handling traffic. Step 3, it safely terminates an old pod in the old replica set. And step 4, it just repeats this entire sequence until 100% of your desired state is reached. Because the Kubernetes service only routes traffic to pods that are fully ready, your users literally never experience a dropped connection during this entire process. It's seamless. Let's dive into section 3, advanced, blue/green, and Canary. Now, as great as native rolling updates are, they do face a few strict limitations. For starters, they offer very little control over the exact speed of the rollout. You also can't easily steer specific percentages of traffic flow to the new version, and they definitely can't automatically abort and roll back if your external metrics suddenly start looking bad. To solve this, the cloud-native ecosystem relies heavily on progressive delivery controllers like Argo rollouts. Argo rollouts integrates directly with your ingress controllers and service meshes to give you absolute, fine-grained control over the blast radius of a new deployment. Through tools like Argo rollouts, you unlock a couple of incredibly powerful patterns. First, you've got the blue/green strategy. This basically spins up the entire new version of your app and links it to a preview service. You can run all your functional tests against this preview completely isolated from live user traffic. Then, once you're satisfied, you just flip a switch and the active service immediately cuts over to the new version. The second pattern is the Canary strategy. This one lets you test the waters with real users by routing, say, just 5% of your live traffic to the new version. If your metrics stay healthy, you can automatically scale that up to 20%, 50%, and eventually the whole 100%.
All right, let's get into the configuration. Section 4, Anatomy of a Deployment. So here is the actual DNA of a deployment file, written out in YAML. You've got the AP version and kind, which simply tell Kubernetes what this object is. The metadata.name provides the base name that gets dynamically hashed to name your replica sets and pods. Down under the spec, you declare your replicas. That's your desired state. But here is the absolute golden rule of Kubernetes deployments. The most important part of this configuration is the spec.template. This is actually a nested pod definition. A rollout is triggered if and only if the deployment's spec.template is changed. If you tweak a container image version or update a label in that specific section, your executive deployment instantly signals the floor managers to start a brand new rollout.
And finally, Section 5, your Rollback Rescue Toolkit.
Look, technical failures during rollouts are gonna happen. It's just a fact of life. You might deploy a container image that can't be resolved, or maybe some application code that just instantly crashes. We have to embrace this reality, and thankfully, Kubernetes gives you a literal superpower for these moments, the ability to hit an undo button. Because deployments inherently manage a history of your replica sets, rolling back to a previous, stable version doesn't require rebuilding your application from scratch. It simply requires telling Kubernetes to scale the old replica set back up and scale the broken one down. To manage this like a pro, you really need these 3 commands in your tool belts. First up, kubectl rollout status. This lets you watch the actual progression of your update in real time. If it gets stuck because of a maxUnavailable constraint in a crashing pod, you are going to see it right here. Next is kubectl rollout history. This one shows you all the past revisions of your deployment. And finally, the absolute magic button, kubectl rollout undo. If you realize a rollout is failing, executing this command instantly instructs Kubernetes to abort the bad rollout and scale back up the previous known good replica set. It is, without a doubt, your ultimate safety net for protecting your users. Which kind of leaves us with this final thought. Kubernetes really proves that with declarative desired states and automation, we can completely eliminate the anxiety of deployment downtime. So if your infrastructure can literally heal itself and automatically roll back a bad update just to save your site, what other manual, error-prone, operational tasks in your organization are just ripe for automation next? Embracing that mindset is the true power of cloud-native computing. Thank you so much for joining me on this explainer. I really hope you found these concepts as fascinating as I do. Keep exploring and keep automating.